Welcome back. Nothing new today. We're going back through integration of logarithms and exponents. I'm going to do a bunch of practice problems. So objectives are still the same. We are integrating logarithmic and exponential functions using U substitution. So I'm going to walk through one example and just realized I didn't update the slide. So change this because this one wasn't possible, but I'm going to write over it, I guess. This should be pi 6. I've changed it everywhere in the problem except right at the top line. There we go. Okay, so I'm going to integrate from 0 to pi 6 of 5 sine 2x dx over cosine 2x. So the first thing I'm going to do is I'm going to try to figure out what the inside function is. Now, whenever I derive the inside function, I should get a dx at the top of my fraction. So if I tried to make sine u, my derivative would be the cosine 2x times 2 dx. That would give me a 2 dx that I have on top, but when I go to substitute, this would be u over part of u prime, because my dx would be on top, but the rest of u prime would be on bottom, so I can't substitute like that. So I'm going to try again, and this will be the bottom part this time, is the cosine of 2x. When I derive it, will be negative 2 sine 2x dx is what I need on top. So that gives me the right trigonometric function for the top of my fraction. Now, I don't have a negative 2, so what I'm going to do is I'm going to write in a negative 2 and divide by negative 2. That way I don't change the original problem. This 5 I can pull outside the integral, since that's just a constant. As for my bounds, I can plug both of my x values into our u function in order to get our bounds. So if I plug in 0, I'll get the cosine of 2 times 0 is the cosine at 0, which is 1. If I plug in pi 6, it's the cosine of 2 times pi 6, which is pi thirds, which is 1/2. So my bounds will become, this 0 will become 1, this pi 6 will become 1/2. And we can do our u substitution. U prime is sine 2x times negative 2 dx. U prime. And then u is cosine 2x. Cosine 2x. That leaves us with a 5 and a negative 1/2 that I can pull out. So that's negative 5 over 2. And then our bounds changed in terms of u. If I integrate u prime over u, I get natural log u. So this is negative 5 over 2 ln u from 1 to 1/2. I plug in 1/2. So that's my upper bound. And then subtract what happens when I plug in 1 for my lower bound. The natural log of 1, log base anything of 1, is 0. So this is negative 5/2 ln 1/2. Any questions on this one? Okay. So I'm going to start calling on people then. So let's go. See, who do I have on Skype first? I've got first up as Kyle. Kyle, what's my u for number 1?
For number 1, 4x to the power of 3 minus 3.
Okay, and what happens when I derive?
It's gonna be 12x squared.
Okay, 12x squared dx. I don't have a 12 though, I've got a 48, so what can I do for this top part if I want to rewrite?
Multiply by 4 and add a 1/4 to outside.
Okay, so I can actually just factor this 48 because I already have a 12 inside that 48. So what times 12 is 48?
4.
4. Okay, so I'm going to pull out that 4, and that'll leave me with the 12x squared dx that I need to substitute for on top, and the 4x cubed minus 3 on bottom. Yes?
Did I miss anything? I didn't get the notification of the Skype is like calling.
That's okay. So we just went over one quick sample problem, and I'm doing a bunch more with everybody else, so you're fine.
I have a the question about the homework that you've sent like last class about the PDF one on like using the provided substitution. Is it purposely changed into u equals x4 x to the 4th power minus 3 instead of x4 minus 2?
You mean for this problem we're working on? Or for the homework one?
The homework one, like it says like use the provided substitution.
Okay, let me take a look at it after we finish the PowerPoint.
Okay.
Um, okay, so far we've done our U substitution. So I'm going to rewrite this in terms of U. Kyle, can you keep going?
In terms of U, so it's equal to. Wait. Oh, okay. So 12x there. So it's U derivative over U prime over U.
Okay, if I integrate U prime over U, what will I get?
U over ln U.
Close. Someone help us out?
Or is it 4 over ln 4?
Nope. So if I integrate U prime over U, I'll get the natural log of U plus C. So if I resub for U, what's my final answer?
Four times mu. I don't know.
What's our U right now?
Oh, our U is 4x to the power of 3 minus 3. Oh.
Okay, and that's it.
Because I'm unsure about indefinite stuff. Because so is indefinite, we don't have like a specific answer?
We don't have any bounds. So you're right, we don't have a specific answer. We don't know what this C is. So there's infinitely many answers that could work. That C could be 0, it could be a billion, it could be any number you want. But all of your correct answers will be in this form.
Okay.
Okay. Moving on to number 2, I've got next on my list, I have Eric next on Skype. So Eric, what do you think my U is for number 2? Okay, I don't think he has a mic active. I'm going to jump to the next person. So this is Abby, you're next.
Is it cotangent minus 3x?
Okay, that's it. We can check. If I derive the cotangent of minus 3x, I'll get negative cosecant squared of negative 3x times negative 3 times dx. So that's a positive 3 cosecant squared of negative 3x dx, which is the right trig function and the right power of x on top. So we're going to go ahead and make that substitution. I have a negative 3, not a positive 3. So what I'm going to do is I'm going to pull out that negative 1.
Negative 1.
Right. And we'll be ready to substitute. Okay, so what happens after we substitute?
You am I right? You derive over U.
That's it. And then I still have that negative on the outside. So if I integrate U prime over U, what will happen?
Negative. U. Negative 3. No. Just negative U prime over U, like same as usual.
Okay, so we've got that. We just need to integrate now. So this is what would I have to derive in order to get 1 over x?
-3.
Not -3.
-1.
Okay, somebody help us out. What do I have to derive in order to get 1 over x?
ln.
Okay, ln x. Okay, I heard it from Niall and Kyle. If I derive natural log x, I get 1 over x. So what would I have to derive in order to get 1 over u?
ln u.
ln u. Okay, and then with chain rule, I'd have to multiply by u prime. So if we integrate u prime over u, I'll get natural log u. And then I've got that negative on the outside that we just pulled out. So this is negative ln u plus c. And then last step, we can go back and sub for u. Our u is cotangent of -3x. This is negative natural log of cotangent of -3x plus c. Okay, any questions on 1 or 2? Okay, next on the list, I've got Nini that just showed up on Skype. I think I'm going to give her a round first, so I'm going to pass Nini for now and we'll come back. So that'll bring us to Niall over on Zoom. Niall, for number 3, what's my u? Niall, what is our u for number 3? Oh. I think my Zoom may have just froze. Okay, here u is just x. Okay, this is not just x. Anyone, what should my u be for number 3?
It should be let me see. -3x.
Okay, I think we're on number 3, not number 2.
Is it -2 plus ln
Oh no.
plus 5x?
Okay, that's it. What happens when I derive?
Uh, 1 over
1
x
over -5x.
times
Negative
-5x times -5.
Okay, that's it. Which means my -5s would actually cancel there. And that would leave me with dx over x for my u prime, which is what I have here, dx over x. So once I substitute right now, I won't have any x's left. Okay, so this is the same thing as the integral of u prime over u. That's 1 over x times dx is my u prime, divided by my u, -2 plus ln -5x. Okay, and if I integrate u prime over u, we said we'll get the natural log of u, so then I can substitute. So that's the natural log of -2 plus ln of -5x plus c. Okay, I think my Zoom is still frozen. I'm going to try stopping the share and coming back. Okay. Who's next? I've got... Okay, Nini's next on my list for Skype. So for number 4,
Yes.
what should my u be?
E to the power of 4 minus 5.
E to the power of 4x minus 5. Perfect. If I derive that, what will I get? If I derive e to the x, I'll get e to the x dx. So if I derive e to the 4x, what will I get?
4e. 3x.
Okay, 4e to the 4x. So that's, if I derive e to some power, I'll get the same thing, e to some power times the derivative of the power. So that derivative of 4x is 4. Okay, then dx. Okay, so we're ready to substitute. If I substitute, this is the same thing as the integral of what? Okay, we need to substitute.
U prime over u.
U prime over u, so that's the same thing as everything else we've done on this page so far. If I integrate u prime over u, I get the natural log of u plus c, and then I can go back and resub for u to get my final answer. So this will be, it's the same thing as the natural log of e to the 4x minus 5 plus c. Okay, so something I haven't been asked yet. Notice I've been using absolute value signs for these natural logs. That's because we cannot take a natural log of a negative number, and we can't take a natural log of 0. So if it's your final answer, you can put those as absolute values. If you put them as parentheses, I will not count them wrong. But if you're going to hand this over to somebody else who maybe doesn't understand the math as well, those absolute values will let them know before you take that natural log. You'll have to make it positive. Okay. Handful more. I'm going to see if I can hear Andrew over on Zoom. Andrew, for number 5, what is my u? Okay, so if I make my u e to the 3x squared plus 5x, when I go to derive that, my derivative will also be e to the 3x squared plus 5x times 6x plus 5. That's, unfortunately, I don't have another e to the power out here, so I need to change my u. That's it. Okay, so my u is 3x squared plus 5. Then my derivative of that would be 6x dx. Okay, I don't have a 6x dx, I've got a negative 30x dx. So what do I have to do? Okay, I could, but I actually already have the 6 inside that negative 30. So is there anything that I could pull out? Okay, I can just pull out that negative 5, because negative 5 times 6 is that 30 already. Okay, so that leaves me with 6x dx on the inside times e to the 3x squared plus 5. So the only thing I've done is I've pulled out that negative 5, and now we're ready to substitute. So what will happen after I substitute? I want to integrate, but we need to substitute to make it in terms of u instead of in terms of x first. Perfect. So that's e to the u prime. What will happen after I integrate? E to the u power plus c. Okay, and then as the last step, I'm going to resub back for u. So this will be negative 5 e to the 3x squared plus 5 plus c. Awesome. Okay, so that brings us back to the top of the round. So I am all the way back to Kyle. Kyle, what's my u for number 6?
You sec 4x.
Okay, the secant
Secant 4x.
of 4x. What happens if I derive that?
Secant. Wait. Secant 4x. What did I forget? Wait. Secant of 4x.
Okay,
Secant of. Oh, wait. Secant tan?
secant tangent. So I've got the secant.
4. Secant 4x tan 4x.
Perfect. Secant 4x tangent 4x times 4. I'm going to write that in front, though, just so I don't accidentally confuse it with the angles and the trig functions. So that's 4 times secant 4x tangent 4x times dx. Okay, I've got an 8th secant 4x tangent 4x dx here, so what could I pull out right now?
2.
2, perfect. So that's 2 times the integral of 4 secant 4x tangent 4x times e to the secant of 4x dx. Okay, so that's 2 times the integral of e to the u prime, if we substitute. What will happen if I integrate?
U, not U. U prime times e to the power.
Okay, so if I'm going to work backwards, I'm going to divide by u prime, and then figure out what I would need to derive in order to get this function. So what would I derive in order to get e to the u prime?
E.
Derive e to what power?
U. E to the U power.
Perfect. So this was originally 2 e to the u power plus c, and then we substitute back in for u, and we're done.
Oh. Okay.
Plus c. Okay, any questions on these two? Okay, last two. Who's next? I've got Eric next, who doesn't have a mic, so I'm going to jump over to Nikita. Nikita, for number 7, what's my u?
U is it 2 plus natural logarithm of x?
That's it. What happens if I derive that?
1 over x times x
Really close. 1 over x times...
times x times well, not just times 1.
Okay, times 1 dx. That derivative of x would normally be 1, but I'm going to write it there just in case x is a function. So that's this chain rule. Okay, so then I'm going to pull out this 5, and we'll be ready to substitute. So if we substitute, then what will happen?
Then it's gonna be just e to the uh, 1. Oh wait, not just 1 over x, and that's it.
I'm going to replace all of my x's with u's. So anytime you see a 2 plus ln x, replace it with u. Anytime you see a 1 over x dx, replace it with u prime. So this would be 5 integral of what?
So it would be 5 integral of e to the 2 plus ln times ln times 2 plus ln to the x.
Okay, this is 2 plus ln x is u. So I can substitute. Anytime I see a 2 plus ln x, I'm going to change it to u. So this will become e to
So
the
just e times u
e to
e to the u.
e to the u power. Okay, and then anytime you see 1 over x dx, I can replace that with u prime. So this is really e to the u times what?
E to the u times u prime.
That's it. Okay. If I integrate e to the u prime, what will happen?
It's just gonna be like 2 plus ln x times 1 over x.
Let's not worry about substituting just yet. So I'm going to leave this in terms of u. What would I have to derive in order to get e to the u times u prime?
Oh, wait. I don't know.
Okay, I'm going to grab somebody to help us out. So next in the order is Nini.
Yes.
When I integrate this, what should happen?
Uh,
So the question is, what would I derive in order to get e to the u times u prime?
E.
Okay, e. So this is, I've got the 5 on the outside, so that's a constant, will stay the same. E to the u power. If I derive e to the x, I'll get e to the x dx. So if I derive e to the u, I should get e to the u du, which is e to the u times u prime. Okay, so working backwards, if you want to integrate e to the u prime, that should get you back to e to the u plus c.
Oh.
Okay. And then last one, next in my order is Niall. So last one for 8, what is my u? E to the x minus 5? Okay. If I derive that, what will happen? Okay, I missed your first part. If I derive e to the x, what will happen? Yes. So my derivative will be e to the x dx. Okay, then I'm going to substitute. I'm going to jump over to Abby. So if I make that substitution, what will happen for this integral?
Is it Do we have to times like -2 in the front?
I do. So I'm going to pull out that -2.
And then u prime over u.
I've got a u prime. I don't have an over u though. Anytime I see e to the x minus 5.
It's itself.
Anytime I see e to the x minus 5, I can replace it with u. So we've got e to the x dx that we just replaced with u prime. And we pulled out the -2. So what I'm left with right now inside the integral is e to the x minus 5. So I can rewrite that as what?
Sorry, I don't know what happened to my.
That's okay. So if u is equal to e to the x minus 5, and what we've got left is e to the x minus 5, how can I rewrite it in terms of u?
E to the power of u.
Perfect. Okay, and then if I integrate, we'll be working backwards. I'm going to jump back to Nikita. What's the integral of e to the u prime?
My internet connection was like keeping like dropping.
Yeah, I'm not sure if it's my end or your end. I'm going to jump back to Nikita just for this last step, because this is where we got stuck last time. So Nikita, if I integrate e to the u prime, what's going to happen? Okay, I've got him cutting off a bit, but that'll be -2 times what? Okay, times e to the u plus c. And then we can substitute. So this will be -2, -2. e to the x minus 5 plus c. Okay, let's see if it'll let me rewrite that. Yeah, there we go. All right, any questions on these last two? Okay. I'm going to throw one more on here, so I'm going to give myself a little bit of blank space. If I derive a to the x, I'll get a to the x times the natural log of a. So for instance, if I derive 4x, I would get 4x times the natural log of 4. So if I integrate, I should do the opposite. Well, when I derived, I multiplied by the natural log of a. So when I integrate a to the x, I should divide by the natural log of a. If you integrate a to the x, you'll get a to the x divided by ln a plus c. So if I integrated 4 raised to the x power, I would get 4 raised to the x power over the natural log of 4 plus c. Okay, and I'm going to stop there. I have sent everyone a list of any missing assignments that you have, if you have any, or a notice that you are not missing any assignments. I've also sent feedback for the draft 1 of the International Day project. I did not give you any feedback for your English mistakes, but I checked all of your math and your citation stuff. So please take a look over your draft one. If you guys have questions on any old homework that you did not submit, so it's been a while and you're trying to fix it before progress reports go out, I will be on and off online through tomorrow afternoon. If you want one-on-one questions, just message me on WeChat and say, hey, I want to Skype, and I'll figure out a time with you one-on-one. If you've got questions on old homework assignments. Otherwise, you guys are free to go. Have a great weekend. If you want to stick around, if you've got questions on that homework, then feel free to stick around. So I think Abby had one.
Yes. For the evaluate each indefinite integral for provided substitution.
Okay, I'm gonna pull it up just so I can see what you're talking about. Oops, this week.
It's a PDF.
Okay. Got it.
Yes, like for the U, is it purposely made to be like that?
Yes, so what they're doing is normally our first step would be to try to figure out what our inside function would be. They're actually giving you that first step. So if u is x to the fourth minus 3, then what would u prime be?
Or x3.
4x cubed times dx. Okay, then you can do your substitution and then integrate.
And then
Yep. So I guess I'm going to finish this one off because we're already here. But so if I do that substitution, right now I've got a -5 that I don't need. So I'm going to pull that out. And then
out.
I need a 4 and I don't have one. So I'm going to multiply by 4 and divide by 4 so that I don't change the original problem. Okay, so that gives me -5 over 4 on the outside of the integral. Times the inside of the integral, I've got 4x cubed dx times 4 to the x to the fourth minus 2. So if I make that substitution, this u is x to the fourth minus 3.
And
Oh, I see. Okay, because this is -2 instead of -3. Was that your question?
yes.
Gotcha. So with properties of exponents, if I have 4 to the -2 power, that's the same as 1 over 4 to the 2 power, right? So I could rewrite this as 4 to x to the fourth power over 4 squared. So if I wanted this to be -3 instead, then this would become 3 instead, right?
Yes.
Okay, if I don't want to change the original problem, then I would have to multiply by another 4 so that one of these would cancel and I would get back to my original 2. Does that make sense?
Are we jumping like? Wait, what?
I'll try another way really quick. So,
I'm so lost.
okay, I'm going to start over. So, I want this to look like this. So what I'm going to do is, right now I've got 4 raised to the x to the fourth minus 2 power. I'm going to subtract 1 and add 1 to this power. So that'll give me 4 to the x to the fourth minus 3 plus 1. Okay, if I'm adding exponents, what I'm really doing is I'm multiplying with the same base. So I'm gonna pull this plus 1 out, and that'll give me 4 to the x to the fourth minus 3 times 4. Okay, now I'm going to rewrite my original problem and we'll keep going from there. So, let's see, if I want to do this on one line, I'm going to throw this part up. 4 to the x, the fourth minus 3 times 4. I'm just doing this to save space so that I can erase this part. Okay, so my original problem is now I'm going to pull out that negative 5 times the integral of, I've got 4 on the outside from this part.
Yes.
X cubed times 4 to the x to the fourth power minus 3 now, times dx. Okay, now I can make my substitution. So this is negative 5 times the integral of 4 to the u times u prime.
Yes.
Okay. If I integrate 4 to the u, when I derive a to the x, I get a to the x times ln a. So if I integrate a to the x, I should get a to the x divided by ln a. So this will become negative 5 times 4 to the u power divided by ln of 4 plus c. And then I can resub per u. If u is x to the fourth minus 3, then my final answer will be negative 5 times 4 to the...
Or x. Do you have a quadrat or what?
I just call it x to the fourth power. I'm not really sure what it should be called though.
And then ln 4.
I think we call it a quartic, but I could be wrong on that.
Quadratic.
ln fourth plus c.
Okay.
Okay, so it's... I can square it, cube it. I can take a quartic, a quintic, and I don't remember what 6 is.
What
Yeah.
about the pentec?
Uh, quintic,
Oh.
quartic, cubic, square. So second, third, fourth, fifth.
Okay.
Okay,
That's it for my question. Thank you.
cool. Anyone else have other questions? If anyone else has stayed, I've got Abby and Niall left, I think.
Yeah.
Okay, so just Niall now.
Abby's gone. Okay. Do you mind if I share the screen?
Yeah, go for it. Let me pull up my Zoom. Okay, I can see you.
Oh. Or you can see my screen right now?
Right now I just see you.
Oh. Oh, I tried to